In this video, I want to talk about what happens when a device needs to send a packet to another device on another IPv4 network. So in this case, PC1 has an IPv4 packet to send to server 0. The source IPv4 address is 192.168.1.101, and the destination IPv4 address will be 10.0.0.99. Okay, so the packet is at PC1 right now, and so it needs to be forwarded. The destination MAC address is 79E9. So right now we're talking about the encapsulation of the Ethernet header and trailer, of course. Now, these two IP addresses are on different networks. So PC1 knows it can't send it there directly. It's like it has to take it to the local post office. Like if you had a letter to send to somebody that was outside your neighborhood, that could be another part of the city, or it could be somewhere halfway across the world. So it does this, you know what? I do know the IP address of my default gateway, my local router, which is 192.168.1.1. We won't talk about this here, but it does determine the MAC address of the local router, the default gateway, which is 9E26. So this is going to be the destination MAC address. It will be the MAC address of the default gateway, the local router on that network. Okay, so PC1 encapsulates the rest of the Ethernet frame and sends the IPv4 packet from its NIC card, PC1, to the NIC card of wireless router 0 in our example, PC1's default gateway. All right, wireless router 0 receives this Ethernet frame. It de-encapsulates the header and trailer, and then it will actually examine the destination IPv4 address in something known as its routing table. We'll do a lookup in its routing table. It determines that it can actually send this packet directly to the destination IPv4 address. It happens to be on the same network as this device. So in this case, it's going to send it out its EC01 MAC address. So that'll be the source MAC address. And it's going to send it to the MAC address of server 0, which happens to be the destination IPv4 address device, the 10.0.0.99 device. Okay, encapsulates the rest of the header and the trailer. And the wireless router now sends this packet from its NIC card to the NIC card of server 0. Notice the IPv4 addresses have not changed, but the source and destination MAC addresses did. Now let's go back the other way. Let's say server 0 has a packet to send now to PC1. So the source IP address of the packet will be 10.0.0.99. The destination IPv4 address of the packet will be 192.168.1.101. Because this Ethernet frame is going to be leaving server 0, the source and MAC address is 6767. And server 0 realizes, hey, the destination IPv4 address is on a different network than me. I can't get it there directly. Same issue PC1 has. Or did have. So server 0 says, oh, well, let me check the IP address of my default gateway. Oh, okay, that's 10.0.0.100. And it also has a method, it's called ARP, Address Resolution Protocol, a method that it determines the MAC address of wireless router 0's 10.0.0.100 address. But anyways, what it's going to do is determines that the MAC address it needs to send it to is that of EC01. So that becomes the destination MAC address. The rest of the header trailer gets encapsulated, and this Ethernet frame is sent from server 0 to the EC01 NIC card of wireless router 0. Wireless router 0 now receives this Ethernet frame, de-encapsulates the header and trailer. examines the destination IPv4 address and determines that it can send it directly to this destination address. So it's going to encapsulate it in a new Ethernet frame with the source MAC address 9E26 and the destination MAC address of 79E9. That's the final destination in this case. Encapsulates the rest of the Ethernet header and trailer and is able to send it from its NIC card 9E26 to 79E9. Once again, same IPv4 packet that server 0 created as far as the source and destination addresses are concerned, but different Ethernet frame, different destination and source MAC addresses.